In this video, I'm going to derive the precise Fisher equation. So start with the definition. The real interest rate is a percentage increase in purchasing power or number of goods that can be purchased from undertaking an investment at a stated interest rate. Suppose you have $1 that you can either 1. Spend today on a good that is priced at $1, or 2. Save at 10% for 1 year and then buy a good that is now priced at $1.05. If you buy the good today, you can afford 1 unit. Okay, you didn't save your money. You have this dollar. You go out to the store. The good is priced at $1. You could afford exactly 1 unit. If you save at 10%, you'll earn 10% interest. So your dollar will grow to $1.10. And then you can spend this $1.10 on a good that now is priced at $1.05. You'll be able to buy 1.1 divided by 1.05 units of this good 1 year from now. So the real interest rate is going to be the percentage change in how many more units of this good you can buy by undertaking this investment. So this is a percentage change formula. If we don't save, we can buy 1 good. And if we do save, we'll be able to buy 1.1 divided by 1.05 units of the good. So we're going to calculate the percentage change in purchasing power. Now note here, R is again the real interest rate. 1.1 reflects 1 plus the nominal interest rate. Just how many more dollars will you have in your account at the end of the year? So it reflects a growth rate in the number of dollars that you'll have in your account at the end of the 1 year. And then 1.05 is just 1 plus the inflation rate. When the price goes from 1 to 1.05, that would be a 5% increase in the price level. And so pi is going to be the inflation rate. So just making these substitutions into the top formula, we've got 1 plus the nominal interest rate divided by 1 plus the inflation rate. And so make that substitution. Since this is all divided by 1, we can just rewrite it like this. So I get rid of that divide by 1 on the bottom here. Moving over to the right, I multiply everything through by 1 plus the inflation rate. Okay, both the left-hand side and the right-hand side. So 1 plus the inflation rate times R. 1 plus the inflation rate is going to also be multiplied by this minus 1 over here. So that's what we got on the right-hand side. Simplifying, we got a 1 minus 1. That cancels. And I multiplied this R through by what's in parentheses on the left-hand side. Solving for I, the nominal interest rate, we now have the precise Fisher equation. This is slightly different than what you see in the textbook. In the textbook, you don't have the real interest rate times the inflation rate showing up in the formula. So let's do the example that we were starting with. The nominal interest rate is 10%, inflation is 5%, plugging that into our precise Fisher equation. Okay. And then solving for R, the real interest rate here is 4.76%. With the textbook Fisher equation, you would just get a real interest rate of 5%. Okay, just one other thing. The textbook Fisher equation is going to be close to the precise Fisher equation when we're dealing with small values of R and pi, the real interest rate and the inflation rate. When they're very small, there's not going to be too much of a difference. But the larger values of R and the larger values of pi, then there will be a difference between the precise Fisher equation and the textbook Fisher. All right, I hope you found this video interesting.